Okay, so you have made it to section 2. Yay! This one is our exponent rules. These are so important. I cannot stress this enough. You need to have these memorized if you don't already. So just like write yourself a little note. I don't care, whatever you need to do. Memorize them. Know them by heart. Recognize them. It will make your life that much easier going through calculus this coming year. So, first rule, this is our negative exponent rule. So if you look at this, we have an x to the negative a. Whenever we see that negative exponent, we do a reciprocal. So we take it, bring it on the bottom, and our exponent is now positive. We can go in the other order as well. If we're at this reciprocal with the negative, we can bring that back up top, and it's a positive here. So if I have 5 to the negative 2, that's just going to be the same as 1 over 5 squared. And 5 squared, we should know, is 25. Now, if we were going the other way, say we had seen something like 1 over 2 to the negative 2, something like that. It's the same thing, you're just doing the reciprocal, you're bringing that back up top. It would be 2 squared instead. Your exponent is now positive, which gives you 4. So it can go either direction here. Multiplication rule, so whenever I multiply, I add my exponent. So if you think about PEMDAS, you're kind of just going down the line for it. PEMDAS. So if I'm at multiplication for my base, that means my exponents go down and add. If I'm at division, they go down and subtract. So it just jumps down 2 here. If I have an exponent to an exponent, I'll multiply. So the rule continues down as we look at this. If that helps you remember it, that's kind of what I do when I'm like having a brain fart and can't remember. I'll think about that, like, oh, it go down a chunk. So here, if I'm multiplying, oh, that goes to addition. So x to the 5th times an x to the 7th, that is going to be an x to the 5 plus 7, or an x to the 12th. Now, down below, our division, well, if I look over here, this division, that goes with subtraction. It goes down a chunk. So, a over b, a minus b. So if I'm here, I have this x to the 12th over x cubed. That means I have an x to the 12th minus 3. Because that 12 on the top is bigger than the 3 on the bottom, we're going to end up with a positive exponent here. So we're going to have an x to the 9th. Don't have to worry about it anymore. But over here, x cubed over x12, we're going to end up with a negative exponent if we subtract. So what we're going to do is we're going to say, okay, well, this is x to the 3 minus 12, x to the negative 9. Now we use that negative rule and say, oh, this is a 1 over x to the 9th. The reason this works out like this is because you're really saying, hey, I have an x times x times x over an x times x times x times an x to the 9th. These 3 are canceling. Okay, we're getting 1 chunk of x to the 9th left on the bottom. Same thing's happening over here if you want to think about it like that. We have an x times x times x times an x to the 12th, sorry, not 12th, x to the 9th, over an x times x times x. So 3 of those are canceling, leaving that x to the 9th behind. Now, the one all my Algebra 2 kids hate, x to the a raised to the b. When I have an exponent to an exponent, that's a power of a power, we're saying, hey, I'm at an exponent. If I go down 1 row, that gets me to multiplication, so you're actually going to be multiplying them here. So I kind of think about this as like 1 row, this is a second row, and then these are each their individual rows. So from exponentials, exponents, we go down to multiplication. So here, what I'm going to do is this 4 is going to multiply by this 3 exponent, which is just a 1. So we're really saying this is going to be a 3, I'm the wrong pens, to the 4th times an x to the 4th. The reason they're to the 4th, though, is not because I'm just bringing this in, it's because these have an exponent of 1. And 1 times 4 is still just 4. So overall, we have an 81 x to the 4th. Another way of thinking about this is you're really saying we have a 3x times a 3x times a 3x times another 3x. So I have 4 x's x to the fourth. Well, 3 times 3 is a 9. These 3 times 3 is another 9. 9 squared is 81. So that's how those work. Say this had been like an x squared here though, so we had squares on each of these. Then we would have ended up with an 81x to the 8th, because 4 times 2 gives us x to the 8th. Last rule we got to learn today. If I have a rational number in my exponent, that's actually the same as a radical. So this radicand is going to be here, and whatever I have in my denominator is going to be what that root is. So if we look at our example here, we have 27 2 over 3. 27 raised to the 2 over 3. So what we can do with this is say, okay, this is actually a cube root, because that 3 was in my denominator, of a 27 squared. Well, the nice thing about this is this 3 and 2 are technically both exponents. So it doesn't matter what order we apply them in. Just like if I have 3 times 3 times 3, well, it doesn't matter what order I multiply them. I'm still going to get to 27. So what I can do is say, rather than squaring this 27 and having to find a cube root of some really large number, I can say, well, the cube root of 27 is just a 3. So I have 3 squared here. And 3 squared, well, that's a 9. So when in doubt, try and apply that radical first. Now over here, I can go that opposite way. If I'm at a radical, I can rewrite it as a rational exponent. So square root of t on the bottom here, I'm going to rewrite that. So this is really a t squared over a t to the 1/2. Now I'm at my division rule. I should subtract. 2 minus 1/2, well, that gives me a 3/2. Finally, okay, now, well, this one we went the other way before, so I could simplify. Now that I'm here, I have to go back and rewrite it as a radical again. My denominator this time is a 2, so I just have a square root of t cubed. I cannot stress the importance of learning these enough. You need to know this. A quick example of how to do this with e is down below, so I'll walk through that with you guys. If you have an e to the x, all the same exponent rules apply. So here I'm going to distribute this e to the 2x, which means I'm multiplying, so when I have multiplication, I should add my exponents. So I have a 3e here, e to the negative x, multiplied my e to the 2x. So 3e, I have that 2x, and it's plus a minus x, so I'm just going to write minus x here. Plus, I have e to the 2x times e to the 3x, so e to the 2x plus 3x. So final thing I'm going to do is combine my like terms. Well, 3e just to the x now, plus an e to the 5x. That would be our final simplified form here. So there's a lot of practice problems for this one. Go ahead and complete those, and good luck.